This discussion is about the slope-intercept formula and how we use this formula to graph the line or the linear equation. Well, let's begin. First of all, I'll start with the formula. Formula is y is equal to mx plus b, where your slope is the m and the b is your y-intercept. Y-intercept. Okay, let's start with an equation like y is equal to 1/2 x plus 1. Now we know that the y-intercept is where it crosses the y-axis, where this line, this equation, crosses the y-axis. So if we were going to graph this line, let's do that. Let's drag this up in our view up here. Let's make it a little smaller. There we go. Alright. If we were going to graph this line, we would first of all, let me get me a marker here, there we go. We would put a dot on this right here, the positive 1 on the y-axis. Remember, this is your y, this is your x-axis. So positive 1, we put a dot right here. Then we'd use rise over run. Now if you remember, rise over run is over 2. You'd rise 1 and run 2. So we go from this point, we would rise 1 and run 2. So we have a dot right there. Rise 1, run 2. Now we can do this one more time. Rise 1 and run 2. And we've got enough dots there to draw our line. So let's use that right there. And our line, let's pull it clean across the graph. Alright. Now, this graph right here represents this equation. The y-intercept is your starting point, and then you use rise over run 1 over 2, up 1 over 2 to plot other points. Once you have a sufficient number, draw you a straight line all the way across the graph. And let's go ahead and label this. Y is equal to 1 over 2x plus 1. Now, there's another type of graph, another equation that we need to discuss. Now let me write it over here. Y is equal to negative 2x minus 1. The difference here is, first of all, our y-intercept is a negative, which isn't that big of a deal, but the negative slope makes a little bit different looking line. So let's first of all follow the steps again. Whenever we have an equation like this, we begin with the y-intercept and plot that point first. And let's use a different color. Okay, negative 1, so we'll start here, get on the y-axis, go down to the negative 1 right there. And here we have a negative 2. So let's first change this to a fraction by putting a 1 underneath it. And then we use rise over run. Rise over run. But there's a little bit of a difference here, because our slope is a negative number and not a positive like we had here. Really, rise could mean the movement up or down on the graph. The run means a movement left or right. So here's what we have to think. If we have a negative slope, negative 2 over 1, that's a negative slope, then our line is going to be decreasing, going this way. So if we use rise over run, we would go up 1, 2, and we'd run in a direction to make our slope negative. So we'd put, or decreasing, so we put our point right there. Let's do it again. Rise up 2 over 1. Now if we wanted, we could go back to our starting point, the y-intercept, and we could go down 2 and over 1 in the direction that keeps us a declining slope. So now we've got sufficient number of points here to graph this line. Let's go ahead and get us a different color. Let's use this color and graph us a line. So our graph looks like this. Alright, let me go ahead and scoot it up some so it, because we want our line to completely cover the graph from one side to the other. Alright, almost there. There we go. And that's the way we like to see our graphs. Let's go ahead and label this one. This graph is, we're going to do this. This one is y is equal to negative 2x minus 1. Notice it crosses the y-axis at negative 1, and we go down 2 over 1 or up 2 over 1, making a negative slope. Remember, when you've got a positive slope, you would do the same thing, but you'd go up and over in the opposite direction, making sure that the line has an increasing slope to it. So keep that in mind when you're graphing slope-intercept formulas. There's another type of formula that we need to discuss right now. Let's use that color. Now this formula looks like this. Y is equal to, let's say, just 2x. Now, notice there's something missing from the two formulas we used before, and that is the y-intercept. We call this a direct variation. Now, direct variation means this, that y varies directly with the value of x, or vice versa. That as x changes, your y changes in the same increments. Okay, so how would we graph this one? Well, in the absence of a y-intercept, we make the assumption that it's going to cross at the origin, right here, right in the center. Alright? Now, again, here's our slope. Slope would be 2 over 1, make it a fraction. It's a positive slope, so it's going to be increasing like this. So we'll do rise of 2 and a run of 1. So rise of 2, run of 1. So we have our point right here. This graph is getting a little busy, isn't it? Up and over. Rise of 2, run of 1. Let's do it again. Rise of 2, run of 1. Always in the direction to make the graph increasing. Okay, let's make this line a blue one. And pull all the way across the graph. Here we go, and we will label this y is equal to 2x. Alright. Now, there are two more types of graphs, the linear equations, that we probably ought to discuss right now so that you're familiar with what they look like. But let me clean this off. Alright, Now, these two equations, if you will, start out looking like this. Y is equal to some number. Actually, any number. It could be, let's see, y is equal to 4, if we will, or y is equal to -3. In either case, it's graphed the same way. This 4 is your starting point. If it's y is equal to, you always start at the y on the y-axis. Again, we know this to be the y, this to be the x. Start on the y-axis and you put a point on the 4 of the y. Positive 4 right there. When it's y is equal to, that means that every point you plot, y must be a 4. So, every point we plot, y must be a 4, so your only options are to plot points on across the line that is equivalent where 4, or where y is always 4. So your line would look like this right here. It runs straight. If it was a -3, you do the same thing. You would plot points where y is always a -3. So your line would always be a straight line across that, across the y-axis at -3. Let's label these. This here is y is equal to 4, and this one is y is equal to -3. Now, there's one more type of equation you need to be familiar with. X is equal to some number. This right here is the same as the y. X could be equal to a 2, or x could be equal to a -5. Works the same way. The only difference is this time it's where it crosses the x-axis. So, for this one, x is equal to 2, you would cross right here, making a vertical line. A line that would make every point so that the x is always equal to 2. This one would be labeled x is equal to 2. And the same for the -5. You would plot a point here on -5 on the x, and you draw the line so that every line, or every point on that line, would be equivalent to, well, would have an x that is equivalent to 5. Alright. And this one, I guess let's label it. This one would be x is equal to -5. So, anytime you have an equation with the y is equal to some number, it is going to be a horizontal line across the x-axis or the y-axis at the point of that number. Horizontal. And if you have an x is equal to some number, it will always be a vertical line across where the number that the x is equivalent to. Now, the slope for a y is known as no slope, or 0. And the slope for an x is undefined. Undefined. Alright, that concludes our discussion of slope and y-intercept formula.